students, welcome back once again. In the previous classes we have discussed about gas laws, in which first we have discussed about Boyles Law. According to Boyles Law, what we have discussed is Boyles Law says when volume and pressure are inversely proportional, means whenever pressure is increased, volume of a given mass of substance, like as we have seen, if you take a given amount of substance of gas in a particular system, and if you increase the pressure, suppose from here, if you give pressure into it, then suppose it reaches here, then what happens? The volume of the given substance will decrease, isn't it? So we can say that volume is inversely proportional to pressure, or pressure is inversely proportional to volume.
You can increase the pressure by adding a weight on top of the piston. Let's add a weight that will increase the pressure on the top of the piston to 2 atmospheres. As the pressure on the gas increases, the volume that the gas occupies decreases. The volume that the gas occupies will continue to decrease until the pressure of the gas equals the external pressure on the piston, which is 2 atmospheres. The volume occupied by the gas will be half its original volume. You should see that the volume is inversely proportional to the pressure. V is proportional to 1 over P. Adding a proportionality constant K, we can write volume equals K divided by pressure, or pressure times volume equals K. This relation is known as Boyles Law, which states that the volume of a fixed amount of gas is inversely proportional to the gas pressure at constant temperature. As the pressure on the gas decreases, the volume that the gas occupies increases. The volume that the gas occupies will continue to increase until the pressure of the gas is equal to the atmospheric pressure on the piston, which is 1 atmosphere.
And second, we have also studied that according to Charles' law, volume is directly proportional to temperature. Means whenever temperature increases, suppose you have taken a ball filled with air, and that particular balloon or ball, if it is allowed to stay outside, like in the sunshine, for a longer time, then what happens? In case of balloon will blast. Why the blasting takes place? Because the air inside air inside the balloon actually increased. That is, volume of the gas increases, okay, when temperature increases. So that's what is explained by Charles' law. In simple terms I am talking here.
Let's use a Bunsen burner to increase the temperature of the gas. As the temperature of the gas increases, the volume that the gas occupies increases. In other words, volume is directly proportional to the temperature of the gas. We can write volume equals K times temperature, where K is a proportionality constant. This relation is known as Charles' law, which states that the volume of a fixed amount of gas is directly proportional to the gas temperature at constant pressure. Note that as the temperature is doubled at constant pressure, the volume that the gas occupies doubles. When the Bunsen burner is removed, the temperature of the gas decreases, and the volume that the gas occupies decreases. The volume that the gas occupies will continue to decrease until the temperature of the gas equals the external temperature. Let's use a Bunsen burner to increase the temperature of the gas. As the temperature is raised, the average velocity of the gas particles increases. Thereby the frequency and intensity of collisions of gas particles with the container walls increase. Pressure, which is defined as the force exerted per unit of surface area, will clearly increase as the frequency and intensity of collisions increase. Pressure for a fixed amount of gas at constant volume is directly proportional to the temperature. Note that as temperature is doubled at constant volume, the pressure exerted by the gas doubles. When the Bunsen burner is removed, the temperature of the gas decreases. The average velocity of the gas particles decreases, Thereby the frequency and intensity of collisions of gas particles with the container walls decrease. Pressure for a fixed amount of gas at constant volume is directly proportional to the temperature.
And according to Avogadro said that, according to Avogadro's law, volume is directly proportional to N. N means number of moles of substance. Volume is directly proportional to number of moles. Means whenever volume of a given mass of substance increases, the number of moles of substances also will increase, isn't it?
Gas particles are entering the container. As the number of particles, or equivalently the moles of gas, increases, the volume that the gas occupies increases. In other words, volume is directly proportional to the number of moles of gas. We can write volume equals K times N, where N is the number of moles of gas and K is a proportionality constant. This relation is known as Avogadro's Law, which states that at constant pressure and temperature, the volume of a gas is directly proportional to the number of moles of the gas. In this animation, the moles of gas particles is doubled, and correspondingly the volume occupied by the gas is doubled.
So now if you see here, in all these cases, this volume is actually common thing. That is, we can say that left hand side volume is directly proportional to temperature also, and number of moles also, and inversely proportional to what? Pressure. Okay. Now if you change the proportionality, we can write it as V is equal to R into N into T divided by P. Okay. Or if you rearrange this one, you can also write it as PV is equal to, that is cross multiplication I have done, PV is equal to nRT. On rearranging we get PV is equal to nRT. Children, this we can say it as ideal gas equation. So today we are discussing about ideal gas equation or combined gas law. What is combined gas law? When you combine the gas laws of Boyles Law, Charles Law and Avogadro Law together, we get PV is equal to nRT. Here this R is actually gas constant. Gas constant. That R is also known as universal gas constant. Now children, this R is equal to, we can also write PV upon NT. Okay, that is gas constant R is equal to PV upon NT, where P and V are pressure and volume, N is number of moles and T is temperature. Now let's put the values in it. That is R is equal to P is 1 bar. 1 bar we can write it 10 raised to 5 Pascal into volume is at standard conditions, volume of gas is 22.71 into 10 raised to minus 3 meter cube divided by number of moles is first when standard conditions 1 mole let us take into temperature is STP temperature is 273.15 Kelvin. So when you calculate this, we get the R gas constant as 8.314, and what are the units are here that you have to write Pascal, PA, Pascal, then meter cube, then we have K and K inverse, mole inverse. Since they are in the denominator, you can write K inverse, mole inverse. Now let us go back into the PV is equal to nRT, where P1, V1 and T1 are the temperatures changes to P2, V2 and T2, means pressure is changed from P1 to P2, volume changed from V1 to V2 and T1 to T2, temperature changes. Then we can write P1 V1 is equal, P1 V1 divided by T1 is equal to nR, or we can also write P2 V2 divided by T2 is equal to also nR. So from these two, we can write it together as P1 V1 by T1 is equal to P2 V2 divided by T2. So this is also equation which can be used instead of ideal gas equation whenever we need to use in the numerical calculations. This equation is also known as combined gas law. Okay. So students, today we have discussed this much only. When Boyles Law, Charles Law and Avogadro Law, when you combine, you will get PV is equal to nRT as an ideal gas equation. Okay. So this ideal gas equation in which this R is our gas constant. Gas constant R can be calculated by using the standard temperatures and pressure when they are in ideal conditions. STP you can say R is equal to 8.314 Pascal meter cube Kelvin inverse mole inverse. Okay, and we can also represent the ideal gas equation in the form of P1 V1 by T1 is equal to P2 V2 by T2. I hope this ideal gas equation and combined gas law you have understood very well. We will study. There are some numerical questions related to these gas laws. We will be discussing those in the coming module. Thank you and have a nice day.